My name is John Casey. I work at Redhat. Today, I'd like to talk a little bit about learning to observe a monolith. I've subtitled this A Diary of Digging Out, and I think that that's appropriate foreshadowing. So let's dive in. First, a little bit about me. I'm a technical lead at Redhat, and I work in an organization that's responsible for our product delivery pipeline. It's kind of a big fancy build system, basically. Does a lot more than your average Jenkins, but we manage the builds for our products. Before that, I worked in the kind of Apache Maven community for a couple of startups, and just generally my experience in my career has a strong emphasis in Java build systems. A little bit about this talk. This is kind of an act or a play in three parts, three acts. So at first we had what I'm going to call primordial production support. This is kind of what a developer might come up with without really knowing anything about operations. We were watching logs on the pod. We didn't even have aggregated logs, and we were doing that from 7 time zones away. At the time, I was I'm in the US, and we had users who were primarily in Europe. And what that meant was that a lot of times I would wake up and, even before I was ready to be at work, sometimes I would have a message waiting for me saying there was a problem in production. And so it was this kind of process of, well, what happened? Okay, let me go look at the logs. Oops, the logs rolled. If we have enough events, then it'll fill up that log file to 100 megs or whatever, and then it'll roll off and create a new log file. And maybe we only have space to keep 20 of those or something. There's a disk space consideration there, but there's also just how much log message or how much log file can you actually get through in a reasonable amount of time to try and find a production problem. So the result of this was often just kind of being dropped in a hole. You didn't have a satisfactory solution. You didn't learn a lesson, and you weren't more prepared for the next time it would happen. So, this wasn't really support. And at the same time, things were fairly slow. We didn't have a really good definition for what constituted fast or slow. But anecdotally, things were slow. Well, how slow? We didn't really know. And why were they slow? We also didn't know that. So eventually, we implemented enough feature that the build system was sort of nominally successful. We could bring products in, and we could have a reasonable expectation that they would be able to do all the steps they needed to be able to actually ship a product. So naturally, this is the thing that everybody's been waiting for, and the floodgates opened. We had products enrolling in the system and starting to try to actually do their work. This meant that the logs were rolling faster and faster and faster as more products ran more builds and there were more things happening concurrently, which also meant that our ability to actually find problems became smaller and smaller because the amount of log volume we were accumulated scales linearly with how many builds are being run. And then the inevitable thing happened. We had a big outage. So for those who don't know, Redhat hosts a yearly event called Redhat Summit. And it kind of functions as a big show and tell for our products. For any new features we're planning to roll out or even new products, there's a big push in the days leading up to Redhat Summit to get those products built so that we actually have something that we can show at Summit. We were right in the middle of that giant river of product builds, and our system wasn't working. We had builds that were timing out, and those timeouts led to data inconsistency. And so we were putting out fires trying to keep the system running, but we were also repairing data. After 3 days of incident response doing this stuff, we finally, out of sheer desperation, we turned on an ad hoc Graphite and Grafana deployment and turned on our metrics. This was something that we had undertaken the previous summer out of kind of a vague sense that logs weren't going to be enough for us. So we had gone and added instrumentation into our code to help us expose metrics for kind of the things that we thought would be hotspots. And we probably leaned a little heavier than we really needed to into the various metrics to be able to see more of the system than maybe what we really needed to do. Anyway, one thing that's really important to know about all this is it was kind of a skunk works. We did this a little bit off the books. Most of what our stakeholders wanted to talk about was features, how fast we were delivering the features. And we had built kind of a little bit of slack into that process and had done some instrumentation work along the way. But we got to that point, that transition point where it was time to actually stand up infrastructure in order to be able to use that code. And that's where the effort kind of fell apart. Anyway, if we fast forward back to the summit, the lead up to summit, when we finally hit that point of desperation, we turned on our metrics system. This is a really kind of rudimentary system. We saw the problem and had a configuration fix within an hour. And then in subsequent weeks and even months after that, we had a really good guidance on how to improve our system, how to make small design changes, add a cache here or there, code optimizations. And all of that made a huge difference, not only to our performance, but also to the reliability of the system. We were losing less data. If things fell apart, we knew more about why, or we could adjust. I liken this to turning on the lights. You can start to see the bugs a little bit more easily. So up to this point, I would say that we've been learning some really hard lessons about what it means to do support in production. And with that transition into producing metrics, there were so many valuable insights that came out of that it changed our thinking. And at this point, I think we've entered a new phase of our growth where we've learned to really value observability and really learning to take support seriously as an intentional practice. So if you fast forward, things actually went pretty well for a while. But then we hit another snag and the build started timing out again. And it was a very kind of vague feeling. Is that slower? Does that seem slower to you? We looked at our metrics and we could see the overall build time starting to creep up. And it's important to note here that from our perspective, as the content provider to the build system, we don't have a really good distinct sense of when a build starts and ends. What we see is a bunch of requests for content. And then at the end, we see a request to validate that content, the stuff that came out. So we don't necessarily have the best view on the system to be able to know whether our overall build times are going up. But in August 2019, the build started timing out again. And it happened right at the end when we were validating our content, is where we started to have problems. Again, our metrics had started to show us a sort of slight uptick, but it was all kind of inferred because we don't have a really good direct measure of build time on our side. We didn't have any really good inflection points down in the deeper metric data that would indicate that we had some kind of a problem. There was nothing obvious to fix here. And crucially, we didn't have a reproducer. There were certain builds that would fail more often, but not reliably enough that we could actually take it offline, take it out of production and do testing to figure out what was going on. At this point, we had aggregated metrics, and we had been using that to guide a lot of our performance tuning and things like that. And we had set up a production support rotation where we were watching those metrics for spikes, among other things. Obviously, other things are involved, but what we found here is that the aggregated metrics gave us an undifferentiated view, especially down in that deeper metric data. And because we have a monolith, we had 9 functions that we were supplying to our build service out of that one service, out of that one monolith. And this meant that there was no way to tell for any given data point down in the deep, especially in the deeper metric data, there was no way to tell which function that was actually coming from. And these smoothing effects down in the deeper layers hid the problems that we were dealing with here. At the end, what we found was that we had a method call that had gone up by 1/10 of a millisecond in terms of how long it took to execute. But that method was being called 10,000 times per request. And because we were validating the output of a build, because of the way that validation worked, we sometimes had like 14,000 requests. And when you multiply all that out, we started to see build timeouts. So sort of ironically, the structured logs saved the day here. Earlier on, when we transitioned into aggregated metrics, another thing we did at the same time was we started shipping our logs off to an Elasticsearch, an elk stack. And we were using, in Java, they call it map diagnostic context, semi-structured logging, basically. We were able to kind of shove in some context variables here and there that would help us with filtering our logs. This kind of saved us because we were able to go back and say, okay, we need information just about this request. We knew that we were seeing aggregate metrics from all over the place and that it was hiding some kind of a signal. We knew there was a signal in there somewhere. So what we did, we started adding a summary log at the end of a request that would kind of summarize how many times a particular hotspot method was called and how long total we'd spent executing in that method. Within a couple of hours of rolling that out, we had built up enough log data from our builds that we could see the problem immediately. And it took us, a little bit of time to design a fix and get it rolled out and then deal with inevitable side effects because we're in a monolith here. But that's how we found the problem, was through our logs. We put metrics into our logs, which sounds absolutely insane to me, looking back. But we needed to be able to measure per request, not per unit of time. This was not straight time series data. That was all jammed together. As a sidebar here, Kibana has been kind of a painful experience for us. We're using this elk stack because it was free to us. We had another team that was already providing it for other use cases. And so we were able to kind of piggyback in on that service. The problem is that it was never designed to be a production grade service. And the stability of that service has been lacking for our uses. But also, Kibana itself isn't the fastest thing. We could probably tune it out. But when you're searching more or less kind of open, an open set of fields, it's not easy to set up really good indexes on that stuff. You don't necessarily know where you need your indexes to be. As a result, our responsiveness in production support has not been great when we have to dive into the logs. We spend a lot of time, sometimes hours, filtering that stuff down to get just the right angle. And then even when that happens, we have engineers who are outside of the US. Kibana, our elk stack is hosted here in the US. When you cross an ocean, the latency in the Kibana interface often causes it to time out. So that becomes a resource that's kind of out of reach for our production support engineers outside the US. And as I'm sure you can see, performance tuning, around the same time, performance tuning kind of hit the wall. For the same reason that we had a hard time solving that production outage or that production problem, we were also unable to see how to make the system faster because all of a sudden, all that data was just kind of smeared together and you couldn't tell one use case from another. Yes, this is a problem with having a monolith, is that you've got multiple functions living in the same house together and it's hard to tune it for multiple functions simultaneously. The metrics really didn't help there because, again, it's all just mashed together. So where we stand today, right now we're in the process of refactoring this monolith. This is kind of a major undertaking. We've had to separate our data domains. I mean, the service that we host is almost all about data, which makes it a very difficult thing to try to refactor. We separated our data domains and we're splitting out these different functional services so that we can kind of address scaling strategies in different ways based on the service. We're creating our SLOs, so we're actually encoding, like writing down and asking people what's the minimum acceptable performance for these various functions. And that's underway now, actually. I'm embarrassed to say it's taken us this long to get here. We're shifting away from our aggregated metrics and into wide events and trace orientation. We're using Honeycomb for that. We're hoping that over time we'll be able to make the case to adjacent teams to help us participate in that trace and to give us a little bit more context to help, because we think that that'll have kind of an outsized impact on our ability as a set of teams, as a pipeline to do support. If we're all contributing context, then that makes it easier to find problems and see how they're related to other things upstream and downstream in the pipeline. We are struggling a little bit with adjacent teams because a lot of those adjacent teams have just started the transition into aggregated metrics, or at least capturing it in a methodical kind of way. At the same time, we haven't quite reached that point where we have something to show for our wide event reorientation. And so we're still in this, we can't show them, we have to tell them about it. And that makes a lot less of a compelling case. So we're hoping to be able to improve that story and continue to kind of build out what we're doing so we can actually show how much it helps. We can see that extending the trace is valuable and adding more context is valuable, but it's a difficult thing. So let's take a step back here and let's think about, why was this journey so hard? And what are the things that we've learned along the way? First thing, and the most important thing, is that you have to be stakeholder zero. Your users depend on you to do support, even if they don't really understand that in a really kind of conscious way. Can you support them? Do you have the tools and the features you need to help? Dropping a support case without any kind of an answer is a really unsatisfying thing to do. And you need to plan for intentional support. You will also need to grow your team. Over time, our build system is being asked to do more and more things, to take on new technologies and be faster. And you need more. You will have a need to grow your team. So the question is, how hard is it to onboard new members into your team? Or another way of thinking of this is, if you're drowning, how long do you have to hold on without help? The complexity of your system really defines that. And then also, you need to be ready to add and remove features quickly. If you identify an opportunity, you need to be able to pivot your design quickly so that you can take advantage of it. Or if you have performance problems, a major performance problem that comes maybe because there's some new use case out there, it's important to be able to shift quickly and fix it so that you don't have to live with the pain. We've really learned that lesson the hard way with the monolith, because shifting out of a monolith is one of these things that takes a lot of work, and there's nothing to show for it until you reach much closer to the end, especially when you have a lot of data to migrate. And in asserting your own position here, in standing up for the importance of operations, it's really important to have management support for this. If managers are all focused on user features, or on what the build system can do, in our case, and they're not worried, or they're not paying so much attention to how stable the build system is, that's going to be a really difficult thing. And so it's important to talk a lot about intentional operations, about observability, and how well you can actually do support, what that looks like, and get management on board with it. Your users care about operations too. If you don't care enough about them, they will care a lot more about them, and then pretty soon those will become user requested features, particular levels of reliability and so forth. At the same time, all user features have an implied minimum performance. That's just basically the SLO discussion. And it's important not to leave those things as implications. You need to chase them out of the system, understand them, write them down, codify them, monitor them. That's a really important part of all this. And it gives you something where you can say, is it broken or is it not broken? If this monitor, if they say that it's broken and the monitor isn't going off, then you've got the wrong thing written down, and it's time to have a conversation about that. And you have to talk, as I said before, talk to stakeholders a lot about operational features. Anytime at the same time and in the same conversations where you're talking about new things to do with the build system, you talk about the way we're going to provide the stability for those new things. And of course, there's got to be a buy versus build slide. So here it is. One lesson that we learned is you have to really respect maturity curves. And of course, we knew going into this that we were starting over, that we had an idea that we could do a build system better than the last one. And we knew to some extent that we were going to have to climb a hill on this. There was going to be a time when our system was less mature, it was less stable, maybe couldn't do as many of the things. But even knowing that, everything you want to do is harder than you think. We have a tendency to look at a kind of visualize the path for implementing a particular feature or a set of features. But that path that we visualize tends to be the happy path. And it doesn't talk about all the brambles on the way and the potholes. It's important to slow down and think about what actually goes into supporting that happy path and trying to keep people on it. Your organizational shape matters a lot in the buy versus build calculation too. Whose budget are new services going to come out of? Especially if you have sort of a platform team and you have a couple of teams doing various stages in the build infrastructure, you know, what budget it comes out of if you want to invest in a new service, that's going to be a bit of a tricky conversation. Also, if there's instability, who feels that pain? Obviously, you know, you have support engineers in different places, but your users also have some downtime where they're not getting builds out the door. It's really important to transmit incentives and transmit the pain across organizational boundaries. If you have a team that's providing a platform and that platform has these kind of transient DNS outages or something like that, things that we can do certain things from our design perspective to surf over those things. But anything that drops a build will produce an outsized impact on the user. And sometimes the platform team can't really see that connection. So it's important to have conversations that span all of that so we can really understand when it's time to buy a service versus just hosting something internally. The other thing here, the last thing about buy versus build is that service prices are easy to understand. They're in dollars or whatever. Team hours and the cost of instability, these things are really hard to quantify. It shouldn't be that hard to quantify team hours, but for some reason, it is something that we tend to undervalue. There are a lot of biases that come into that second half of the equation, where we just basically systematically undervalue it. For instance, how many times have you been in a meeting, maybe with a lot of other people, where you didn't really say much and maybe didn't get all that much out of it? How much did that meeting cost the company? You know? The last thing I'll drop in here is it's important to respect your lack of understanding. And that sounds funny, but developers, and I think managers to a certain extent, tend to be very optimistic about what they can do and how fast they can do it. And it's important to be kind of suspicious of that, be skeptical of it. As I said, we have a tendency when we're visualizing how to solve a problem, we're thinking about the happy path. It's important to slow down and go, okay, well, we have these other things that can go wrong. And our ability to see that up front is very limited. We may have written the code. We may have written every line of the code. We may understand it back to front. When you put it in production and you start putting load on it, things are going to surprise you and things will blow up. And so the question is, when you're in that situation, what tools do you have to figure out what's going on and get it solved? And metrics and things like that are really good at detecting problems that you've already had. I think about these aggregated metrics that we have sometimes, and they're kind of like pickets. You know, they're watching for the last problem in case it comes back, and it's an important thing. But by definition, if you have a problem in production, it's one of the hardest problems you're going to encounter. It would have been caught by tests otherwise. So by definition, if it happens in production, it's likely to be more serious and more difficult to fix, understand even. It's important to have tools that'll help support you in that. So just as a really quick summary, I would say 3 big lessons that we learned is that we need to be stakeholder zero. We need to really intentionally design for operations. We need to consider our biases that go into buy versus build, and think really hard before we decide to just host another service. That comes with its own support load. And then last, really favor tools that support you in exploring the system. Understand that you don't understand the system as well as you think you do. You never will. There will always be things that come in sideways, and it's important to have something that's going to support you when you're in an unfamiliar situation. And I'd say that that's pretty much what we've learned by trying to stand up and observe our monolith. Are there any questions?
Thank you, John. What a journey. That sounds like it was a real progression through a lot of changes.
I would say we've learned a lot, yeah.
There was one thing you talked about there that really keyed in for me and resonated from something Rob Meany said yesterday in his talk. He said, we write our application code tests when we know the least about how our code operates in production. And in your talk, you were saying that at the beginning, when you were adding those first metrics, you were adding things you thought were going to be hotspots, but you didn't know. This consistent guessing before you actually get to the place where your application is running, it seems a theme that cuts across so much of what we do as developers. Even when we got to tracing, you think about what might be a reasonable boundary of a unit of work. Do you think that we can shorten that arc? Can we guess better, or is this just a necessary part of a circular process?
So I think that we are always kind of stuck in this trap a little bit of kind of fighting the last battle, having the best information about things that we've already tripped over. I would say that I've learned some interesting things while we've been going through the actual methodology, how we're actually going to break up the monolith. It's forced us to think about like separating our data domains. And of course that introduces we have to grapple with how much latency we're going to have once we've separated those things. And I feel like that puts us in a position where we can think a little bit more intelligently about what kind of metrics might blow up on us. And of course, part of the problem here is that if it gets to production, there's a good chance that the thing that goes wrong is missing your guess, right? I mean, it's the thing you didn't guess about. But I do think that if we understand what are the important dynamics, what are the important pieces in play, that we can put in some kind of measurements around those things and then maybe have a better shot at seeing that. And the other thing I'm really looking forward to out of really diving all the way into Honeycomb is being able to take those things and then kind of cross-cut them in different ways. Mm-hmm. What I always try and do when we have a production problem is I wind up, you look at it this way and, well, maybe if I shift a little bit to the left and kind of come in from this angle, and you can see it from different angles and you get a better picture of the problem. I'm hoping that being able to cross-cut in different ways will give us better visibility on those things.
But, it's like you said at the end, though, the fact that it's manifesting in production makes it the hardest problem that you could have, because otherwise you would have caught it already.
Yeah. And that's, honestly, I think this is the best argument in favor of just queryability, right? It's not just having a dashboard, it's having the ability to go and explore your data. And then the only thing you really have to worry about is having the right data.